Today I want to announce that the team behind NASA's Juno mission has transformed data collected during 2 close passes to Jupiter into animations, highlighting 2 remarkable features of Io. These are a mountain and an almost glass-smooth lake of cooling lava. Among other recent scientific findings from the solar-powered spacecraft are updates on Jupiter's polar cyclones and water abundance. These new findings were announced by Juno's principal investigator Scott Bolton on Wednesday, April 16th, during a press conference at the European Geophysical Union General Assembly in Vienna. Juno made extremely close passes to Io in December 2023 and February 2024, getting as close as about 930 miles to the surface, capturing the first close-up images of the Moon's northern latitudes. Bolton says, "Io is simply littered with volcanoes, and we caught a few of them in action. We also got some great close-ups and other data on a 200-kilometer-long lava lake called Loki Patera. The reflection of the lake captured by our instruments indicates that some parts of Io's surface are as smooth as glass, reminiscent of obsidian glass created by volcanoes on Earth." Juno's microwave radiometer (MWR) instrument-generated maps reveal that Io not only has a relatively smooth surface compared to Jupiter's other Galilean moons, but also has poles that are colder than middle latitudes. During Juno's extended mission, the spacecraft gets closer to Jupiter's North Pole with each pass. This changing orientation allows the MWR instrument to improve its resolution of Jupiter's northern polar cyclones. The data allows for multi-wavelength comparisons of the poles, revealing that not all polar cyclones are created equal. One of the most striking examples of this disparity can be found with the central cyclone at Jupiter's North Pole, says Juno's project scientist Steve Levin. "It is clearly visible in both infrared and visible light images, but its microwave signature is nowhere near as strong as other nearby storms. This tells us that its subsurface structure must be very different from these other cyclones." The MWR team continues to collect more and better microwave data with every orbit, so we anticipate developing a more detailed 3D map of these intriguing polar storms. One of the mission's primary scientific goals is to collect data that could help scientists better understand Jupiter's water abundance. To do this, the Juno science team isn't hunting for liquid water. Instead, they are looking to quantify the presence of oxygen and hydrogen molecules in Jupiter's atmosphere. An accurate estimate is critical to piecing together the puzzle of our solar system's formation. Jupiter was likely the first planet to form, and it contains most of the gas and dust that wasn't incorporated into the Sun. Water abundance also has important implications for the gas giant's meteorology and internal structure. In 1995, NASA's Galileo probe provided an early data set on Jupiter's water abundance during the spacecraft's 57-minute descent into the Jovian atmosphere. But the data created more questions than answers, indicating the gas giant's atmosphere was unexpectedly hot and, contrary to what computer models had indicated, bereft of water. The probe did amazing science, but its data was so far afield from our models of Jupiter's water abundance that we considered whether the location it sampled could be an outlier. But before Juno, we couldn't confirm, says Bolton. Now, with recent results made with MWR data, we have nailed down that the water abundance near Jupiter's equator is roughly 3 to 4 times the solar abundance when compared to hydrogen. This definitively demonstrates that the Galileo probe's entry site was an anomalously dry desert-like region.